Hello, everyone. Welcome back. In this lecture, we are going to study one of the most important ideas in finance: future value, present value, and the logic of discounting. This topic may look mathematical at first, but the idea is very practical. A dollar today and a dollar in the future are not the same in economic value. The reason is simple. Money today can be invested. It can reduce borrowing. It can be kept for emergencies. It can also be used for another business opportunity. So when managers analyze cash flows, they cannot simply add dollars that arrive at different dates. Timing matters. A cash flow today is already in today's dollars. A cash flow in the future must be adjusted before it can be evaluated properly. Finance gives us two powerful directions of movement. Future value moves money forward in time. Present value moves money backward in time. Once we learn these two movements, we can understand investment growth, project evaluation, discount rates, interest rates, and many valuation decisions. Today, we will build this logic step by step, slowly and clearly. Let's begin with a timeline, because a timeline is one of the simplest and most powerful tools in finance. A timeline shows when cash flows occur. It prevents us from making the common mistake of treating dollars at different points in time as if they are identical. Think of time 0 as today. Time 1 means one period from today. That period could be 1 year, 1 month, 1 quarter, or another consistent interval. The important word is consistent. If the interest rate is annual, the period should usually be 1 year. If the cash flows are monthly, the rate should be monthly. A large number of finance mistakes happen when someone uses an annual rate with monthly periods or a monthly rate with annual periods. On a basic timeline, we may have a cash flow today called C0 and a cash flow later called C1. C0 is already measured in today's dollars. C1 is not. To compare it with today's dollars, we need to discount it. So, before using any formula, pause and ask, what is the cash flow? When does it happen? What is the rate per period? How many periods are involved? Now, let's move money forward in time. This is future value. Future value measures what an amount today will become later if it earns a given rate of return. In simple language, future value asks, if I invest money today, how much will it grow to in the future? For one period, the formula is FV1 equals PV times 1 plus R. Here, FV1 is the future value one period from today. PV is the amount today. R is the rate of return per period. If there is more than one period, the formula becomes FVN equals PV times 1 plus R to the power of N. This is where compounding enters the picture. Compounding means that interest is earned not only on the original investment, but also on interest from earlier periods. For example, suppose $10,000 is invested for 3 years at 8% per year. The future value is FV3 equals 10,000 times 1.08 to the power of 3. That equals $12,597. Notice what happened. The investment did not simply earn interest once. It earned interest, then interest on interest, and that is the beginning of compound growth. Compounding becomes more powerful as time becomes longer, as the rate becomes higher, or when both happen together. This is one of the most exciting ideas in finance, because the effect is often small at first and dramatic later. $1 invested at 4% for 1 year becomes $1.04. At 8%, it becomes $1.08. At 12%, it becomes $1.12. After 1 year, the difference looks modest. But over longer horizons, the difference becomes much larger. After 30 years, $1 at 4% grows to about $3.24. At 8%, it grows to about $10.06. At 12%, it grows to about $29.96. Same beginning amount, different rates, longer time, very different outcomes. This is why timing matters so much in saving, investing, business planning, and project evaluation. The earlier cash is invested, the more time it has to earn returns on prior returns. Compounding also affects forecasts. A small difference in growth assumptions can become a large difference in future value. That is why managers must be careful with long-term projections. Now let's reverse direction. Instead of moving money forward, we move future money backward to today. This is present value. Present value measures what a future cash flow is worth today. It asks, how much would we need today to be economically equivalent to receiving a certain amount in the future? We start with the future value formula. FVN equals PV times 1 plus R to the power n. Then we rearrange it to solve for present value. PV equals FVN divided by 1 plus R to the power n. The expression 1 divided by 1 plus R to the power n is the present value factor. It converts a future dollar amount into today's dollars. Suppose a customer promises to pay $50,000 3 years from today. If the appropriate discount rate is 9%, the present value is PV equals 50,000 divided by 1.09 to the power 3. That equals $38,609. This does not mean the $50,000 future cash flow is bad. It means that waiting has a cost. Present value adjusts the future amount for the return that could have been earned during the waiting period. Discounting is central to financial management because most business decisions involve costs and benefits that happen at different times. A machine may require cash today but produce savings in the future. A marketing campaign may require spending now while additional revenue arrives later. A credit policy may increase sales, but it may delay cash collection. So the manager's job is not simply to ask, are there future benefits? The better question is, are those future benefits large enough, soon enough, and reliable enough to justify using resources today? For a single future cash flow, the decision logic is straightforward. If the present value of the future cash flow is greater than the required cost today, the decision may create value. For example, suppose a firm spends $75,000 today on an equipment upgrade. The upgrade is expected to produce a single cash inflow of $95,000 in 2 years. If the required return is 10%, the present value is PV is 95,000 divided by 110 to the power 2. That equals 78,512. Since 78,512 is greater than 75,000, the project appears to create value before considering taxes, implementation costs, and operating risk. Now we must understand the discount rate more deeply. The discount rate is not just a number we insert into a formula. It represents an opportunity cost. Opportunity cost means the return that could be earned on a comparable alternative, with similar timing and risk. If money is invested in one project, it cannot be invested in another project at the same time. For example, if investors can earn 8% on an alternative investment with similar risk, then a new investment should generally be expected to earn at least 8% to justify committing capital. The discount rate usually reflects three major forces. First, time. Investors prefer earlier cash flows because earlier cash can be reinvested or used. Second, inflation. Future dollars may buy fewer goods and services than dollars today. Third, risk. If a future cash flow is uncertain, investors require compensation for bearing that uncertainty. This risk component is very important. A safe cash flow should usually be discounted at a lower rate than a risky cash flow. If a manager uses the same discount rate for every decision, risky projects may be overvalued and safe projects may be undervalued. One of the most important relationships in finance is this: higher discount rates reduce present value. Let us think carefully about why. A higher discount rate means the future cash flow must compete against a more attractive alternative return. It may also mean that the future cash flow is riskier and therefore requires greater compensation. Consider a $100,000 cash flow to be received 5 years from today. At a 4% discount rate, its present value is about $82,192. At an 8% discount rate, its present value falls to about $68,058. At a 12% discount rate, it falls to about $56,743. At a 16% discount rate, it falls to about $47,638. The future cash flow is the same in every case. The only thing changing is the discount rate. This is why valuation is sensitive to required returns. When market discount rates rise, the present value of many future cash flows decreases. When market discount rates fall, the present value of many future cash flows increases. This logic helps explain why interest rate changes can affect bond prices, stock valuations, real estate values, and long-term investment decisions. Now, let's discuss stated rates and effective rates. Interest rates are sometimes quoted in a way that does not fully show the true annual rate earned or paid. A loan may quote an annual percentage rate, but interest may compound monthly, quarterly, or daily. To use time value of money correctly, the rate and the period must match. A stated annual rate reports the annual rate before adjusting for compounding within the year. If the stated annual rate is compounded m times per year, the periodic rate is equal to stated annual rate divided by m. The effective annual rate is the actual annual rate after compounding is included. For example, suppose a loan has a stated annual rate of 12% compounded monthly. The monthly rate is 1%. The effective annual rate is 1.01 raised to the power of 12 minus 1. That equals 12.68%. So, the borrower pays more than 12% on an effective annual basis because interest is charged on prior interest during the year. The lesson is simple. Always match the rate, the compounding frequency, and the timing of the cash flows. Before we finish, let us review the most common timing mistakes in time value of money analysis. The first mistake is using the wrong number of periods. A 5-year monthly setting has 60 monthly periods, not 5 periods. The second mistake is mixing rates and periods. Monthly cash flows require a monthly rate, unless the analysis has been properly converted. The third mistake is ignoring compounding. A stated annual rate compounded monthly is not the same as the effective annual rate. The fourth mistake is confusing value with profit. A present value or future value calculation measures economic equivalence across time. It does not automatically measure accounting profit. A disciplined timeline helps prevent these mistakes. Before calculating, identify the cash flow amount, the timing of the cash flow, the rate per period, and the number of periods. The larger managerial lesson is powerful. Financial value depends on amount, timing, and risk. Future value helps us understand growth. Present value helps us understand today's value of future money. Discounting helps managers decide whether future benefits justify resources committed today. Thank you for joining me today. I'll see you in the next video.